Hello viewer, welcome to our channel. Today we're going to know about, can quantum mechanics and general relativity coexist? The world of physics is currently grappling with a fundamental problem: how to unify the laws of quantum mechanics and general relativity. These two theories describe the forces of nature in vastly different ways, and scientists have yet to find a way to reconcile them. General relativity, which is currently our best model of gravity, describes the force as a geometric interpretation. According to this theory, the presence of mass distorts the space-time grid, like a bowling ball sitting on a stretched rubber sheet. Particles then move along the shortest paths on this distorted grid, and this is what we interpret as the effects of gravity. On the other hand, quantum mechanics, through what is known as the Standard Model, explains the other three forces of nature: the electromagnetic force, which affects electrically charged particles; the strong nuclear force, which holds particles in nuclei together; and the weak nuclear force, which governs some radioactive decays. In the quantum mechanical picture, forces arise through the exchange of virtual particles. These particles pop into existence for a short time and then disappear, and while they have no analog in our familiar world, the Heisenberg uncertainty principle allows them in the subatomic world. The problem is that at high enough energies, the three quantum mechanical forces merge together while gravity remains separate. This has led to the search for theories that can unify the two. Two main theories that have been proposed are string theory and quantum loop gravity. In string theory, the basic building blocks of matter, such as quarks and elementary particles like electrons, are made of even more fundamental objects called strings. In quantum loop gravity, spacetime itself becomes granular at very small distances. Both theories suggest that gravity can be generated through the exchange of virtual particles called gravitons. Currently, the question of which theory, if any, is correct is still being investigated by physicists. The search for a unifying theory is one of the most challenging and important problems in physics today, and it has the potential to revolutionize our understanding of the universe. If you like the video, please like, share and subscribe our channel. Thanks for watching. See you in next